I'm Vidya, Community and Content Specialist at PI Exchange. Welcome to our webinar on using no-code machine learning for price optimization. Thank you for taking time out of your busy schedule to join us today. We promise you it will be worth your time. Let me first introduce our company. PI Exchange is a deep tech company making AI accessible to everyone. Our flagship product, the AI and Analytics Engine, is a no-code end-to-end AutoML platform. With the engine, you have machine learning at your fingertips without having to write a single line of code. This is particularly helpful for users who may not have the technical expertise or any coding knowledge but still want to use machine learning. For today's session, I am joined by one of our expert data scientists, Dr. Kathy Sarafrazi. She will be walking you through how you can build a machine learning model to optimize pricing using the AI and Analytics Engine. What is the AI and Analytics Engine? The engine takes you from raw data all the way to model deployment without any coding necessary. It streamlines the traditional end-to-end machine learning process and empowers anyone, even non-technical users from any industry, to create and deploy their own machine learning models to get predictions from. The ability to accurately optimize pricing is helpful for any industry involved in the sale of products or services. By using machine learning, executives in these industries can identify the right prices to set their products at. Doing so allows them to make data-driven decisions to optimize their pricing strategies. A study by IBM revealed that 73% of retailers expect their companies to use automation in the pricing and promotion realm. It's happening. Intelligent pricing is growing in popularity among retailers. So here comes my next question. By how much do you think price optimization can boost sales? The answer is 25%. That is a significant amount of sales that is just waiting to happen. You can attain this boost in sales simply by optimizing your pricing strategy using machine learning. Today's retailers face increasing competition, which is why an optimal pricing strategy is important. By using machine learning, you can analyze a multitude of internal and external variables that affect pricing. For example, competitor trend, market trends, competitor pricing, the price of raw materials, and more. With input from various sources, you can take into account more data. This provides more accuracy in your pricing strategy. Using the information from all your sources, you will make data-driven decisions on pricing. This enables you to price products and services optimally for both yourself and your customer, leading to enhanced customer loyalty. Furthermore, you will be able to predict how your customers will react to product prices, be it due to a change in product price or when introducing a new product line. This essentially sets you apart from your competitors and supercharges your revenue. Next question. What percentage of shoppers choose to shop at their favorite retailer solely because their pricing was good? The answer is 60%. 60% of shoppers choose to shop at their favorite retailers solely because their price was good. It takes optimal pricing to be a consumer's favorite retailer, and that is where machine learning can help. Let's get into the dataset that we will be using for the demonstration. We will be using a publicly available dataset from Kaggle that looks at transactions of apparels in a store. We will use this to predict the best price to sell products at. Dr. Kathy Sarafrazi will now walk you through the use case. Over to you, Kathy.
Thank you, Vidya, and hello, everyone. Before we jump onto the platform, I'm going to go over the overall process of creating a machine learning model on the AI and Analytics Engine. First, we're going to start by importing our data. We can do this by either connecting to a database or uploading our file directly. When our data has been uploaded, we can prepare the data in our data wrangling stage. In this stage, we will do any sort of data cleaning or data transformation that we might need to make our data machine learning model ready. When we have done that, we can go ahead and select the feature and the target columns. The feature columns are going to be the input columns that we want to use for our machine learning model, and the target column is going to be the column that the model will be predicting. After that, we can select from the list of the models that are available on the models that we want to train, and go ahead and train them. And once they've been trained, we can evaluate different models and compare their performances to decide which one suits our use case best. And once we've chosen the best model, we can go ahead and deploy the model and use it for our application. All right, let's go ahead and jump onto the platform. Today, we're going to be using a data set that contains sales information for different apparel pieces in a retail store. We have some information on the product, like the gender, category, brand, and so on. The price that was set for that product and that particular date. And we have the number of units sold. Our goal is to create a machine learning model that would take in the information about the product, the price point, and it would give us the predicted number of sales. So we can use this model to predict the amount of sales for different price points, and we can go ahead and choose the best price point basically for our product on each date. This way we will optimize the price that we set for our product. All right, let's get started. We're going to start on our home page on the engine. I'm going to go ahead and create a new project. I'm calling this price optimization project. Create. So the first step here is to add a new data set. You can see we have a range of different databases to choose from. I'm going to upload the file directly. Throughout the demo, some of the steps might take a few seconds to complete, so I will go ahead and move on to the end result. This will take under a minute. Once the data has been uploaded, the engine shows me a preview of the dataset. I can go ahead and double check that all the columns have been read correctly. Seems so. So I'm going to go ahead and rename this and press next. Here the engine is showing me the data type that it has detected for each of the columns. So for example, ID, SKU ID, this has been detected as numeric. Brand, collection, price tier, this has been detected as text. If I'm not happy with any of these, I could change it, but I'm just going to go ahead and keep this to the default values and create the data set. When the data has been created, the engine will ask us if we want to create a new data wrangling recipe or we want to process the data using a recipe that we already have. Here, I don't have a recipe for this, so I will create a new data wrangling recipe. A data wrangling recipe will contain my steps that I want to take for cleaning and transforming my data. And the benefit of using a data wrangling recipe is that once you have created a data wrangling recipe, when new data comes in, you can go ahead and just use that old recipe to process the data. And as you know, in data analysis and data science, a vast majority of your time could be spent on preparing your data before you get to the main analysis or modeling. So here, by using this saved data wrangling recipe, you can cut that time out and save a good amount of time. Okay, our data wrangling session is being processed. First time you're starting a new session, it might take a couple of minutes, but the next time it will load really fast. I'll go ahead and use a recipe session that is already ready here. On the left hand side, I have a preview of the data set once again. Our goal once again is to predict the amount, create a model that would predict the amount of sales based off of the other columns. And we can use that model to predict the sales for different price points and use that information to choose the optimal price point for each day. Okay, on the right hand side here, I have my recipe panel. The first tab is suggestions. In this tab, you can see some suggested steps that the engine is making to process our data and get started with our data wrangling. If I want to see more details about any of these suggestions, I could have a look at the analysis. So for this first one, it's suggested that I convert date column to datetime, and the reason for that is that the streaks that are in this column are in datetime format. This is a correct suggestion, so I will click here to add it to my recipe. You can see this has been now added as the first step of my recipe. And if I go back to my preview panel here, the date column has been converted to datetime type, and it's not a text anymore. Let's go back here. I have another suggestion to convert some other columns to categorical. I could have a look at the analysis here. We can see, for example, the gender column has only 2 unique values. And this is a correct suggestion as well. So I'll go ahead and add it. And we can see that gender is now converted to categorical from text. And this is our first 2 actions in our recipe. We don't have to just use the suggestions to select new actions. We could add actions from the action catalog. We have a wide range of different actions that you could choose from. These could be actions used to clean out the data, fill missing values, deal with time series data, deal with different types of data, natural language processing, and so on. But we don't have enough time to go over all of them, obviously. I'll just use an action to create a new column with a formula. What I want to do is I want to calculate the sales price in dollars. The price that we see in this price column is basically the ratio of the sales price to the cost of that merchandise. So if we see 1.8, this means that we're selling the product at the 80% margin. But if we want to know what that price point actually is, we can go ahead and multiply this price by the cost. So I'm going to name this sales price. And the formula for this is going to be price multiplied by cost. As you can see, the engine is suggesting column names here as variables for me. I could easily write down the formula and use the column names as variables in the formula. It's very simple, similar to the formulas that we have in Excel, but the benefit here is that you can apply these formulas to really big data sets, and you won't have the limitations that Excel has in dealing with data size. Okay, so this is our sales price. So for example, for this product, the sales price is actually $78 and so on. We could create another column and calculate the profit made of this product in this particular day. So total profit will be sales multiplied by sales price minus cost. So for this particular day, for this particular product, we made $14,700 in profit. Okay, I'm happy with our data wrangling at this stage. So I'm going to go ahead and commit my actions. Once the actions have been committed, you can no longer edit them or remove them from the recipe. And when the committing is finished, this would take around a minute. You can go ahead and finalize the recipe and save the output to a new data set. Okay, I'm going to call this Okay, this is a data set that we just created. If we want, we can download it here. If we would like to use it in another capacity to create visualizations or use it off the platform, we could do that. If we want to create another recipe to process it this data further, we could create a recipe. We could also have a look at the analysis for this data set. Here we have the distribution of the values in different columns. So for example, in terms of sales, you can see most of the products sold under 400 units a day. If you want, we could check out the other columns. I'm going to go ahead and use the data to create my machine learning model. To do that, I will be creating an app. I will name this Sales Prediction App. This is going to be a prediction task. Our target, as we talked about, is going to be the sales column next. But we'll be keeping it to the default configuration. But if you want to, you can use the advanced config. Okay, my app is being processed here. I will go ahead and use an app that's already ready here and create my machine learning model here in my app. So the first step here, as we talked about, is going to be creating our new feature set. The features are going to be the input columns that we want to use for our model. I'm going to name these features. Next, here the engine is showing me a list of the columns that are available in the data set, and I can select which ones I want to include in the feature set. I will select SKU ID price. I won't select SKU name because there's a one-to-one relationship here and there's no more additional information between SKU name and SKU ID. We're selecting gender, category, brand, collection, price, style, cost, year, month, and so on. Let's select these. I'm not going to select day of month because that's not that relevant, but day of week could affect the amount of sales. This feature set is being processed. This might take a couple of minutes. I'm going to go ahead and use this one that's already ready and train a new model. Next. Here I have the list of models that are available on the engine. I can select the ones that I want to train. We have a wide range of both CPU and GPU models here available. If we're not sure which one we want to select, when we choose it, we can see the engine is using AI to predict how this model will perform and how long it will take it to predict new samples for us. So we could use this information to choose the models we want to train. Unlike other platforms that basically run a portion of the data throughout all of the models to give you this information, the AI and analytics engine uses AI to predict these values. So that can save you some computation. Here, I'm going to keep it to the default configuration, but if you're a more advanced machine learning user, you can adjust the hyperparameters. You can see the models are being trained in parallel here. In data science, it's very common to train multiple combinations of the feature sets and machine learning models. So we can use this information to compare the performance of each. And being able to train in parallel can save us some time in that regard. We already have some models that have been trained previously. So we can go ahead and have a look at the model leaderboard. Here we have a summary of the performance of different models. We can see like GBM regression is the one with the highest prediction quality. XGBoost is the one with the fastest prediction time. And Random Forest is the one that trained faster. So we can use this information to choose which model suits our application best. Do we want to sacrifice a little bit of performance to get faster predictions? Or no, we want the one that has the highest prediction quality. Let's say we want the one with the highest prediction quality. We can go ahead, take a look at the details of this model's performance. We have the prediction error, percentage error. If we want more details, we can have a look at our performance tab. We have a good option of different metrics and charts if we want to basically evaluate the performance of our model. Let's say we're happy with this model and we want to deploy it. Our next step is going to be to deploy the model. Okay, I'm going to go ahead and deploy this model. Next, deploying to PI Exchange Cloud, deployment name, creating a new endpoint. Okay, once our deployment is ready, we can go ahead and use the endpoint to call the model to make predictions. Here, we could use the basically API keys to call the model when we get new data coming in. So if you have a dashboard in place, you could use this endpoint to make predictions and for your new data points. Otherwise, if you want to make predictions directly on the platform, you could upload your files here to generate a batch prediction and get the prediction values for these new data points. Something else that we can do here is that once we have our deployment, we could go to the explainability tab on our model and here do what if analysis. So in this analysis, we could change the input parameters into the model, which will be the product details and the price point here, to see how that would affect the predicted sales. Here, for example, for this particular product, for the price of 1.5, we have 1,186 units of sale predicted. If I increase this price, so let's say I increase it to 2, we can see now we have 600 predicted sales. So we can see how changing the price point changes the predicted amount of sales. So to optimize the price for a particular date, what we could do is we could run the model for different price points for a particular product on a particular day and choose the price point that gives us the maximum profit. Here I have a very simple dashboard that calls the model, basically the model that we just saw. I could adjust the product features here, and I could give the day that I want to make the predictions for, and it will run the model for different price points and give me the amount of sales and the profit that we will have for that price point. So obviously, as you increase the price, the amount of sales decreases, but we can see that there's basically this sweet spot that we have the maximum profit. For this product, for example, on this particular day, we have the optimal price of 1.44 with 915 units of sale, and that will give us $14,000 in profit. So this will be this point in the graph. If we want, we can change the product to see what for different products. Let's say for our product 3, which is casual jeans for women, we could see how the model predicts different sales points and what our optimal price point will be. So here for this one, once again, the optimal price point is 1.4. But we can see how our profit changes as we change the price point. If we want, we could manually also change the product features. Okay, that's it for our demo today. If you have any sort of questions, I'd be happy to answer them. And I'm curious to know, now that we have gone through this, what do you think holds you and your organization back from integrating machine learning and AI into your price optimization process, or generally integrating machine learning into your company for any sort of use case that you think you might have? Okay, thank you. And you can ask your questions if you have any.
Thank you, Kathy, for taking us through the demo and showing us how to optimize pricing. To summarize, you can see that by simply using the data that you already have on your customers and transactions, you can build your own predictive model to start optimizing pricing. All this is done in the AI and analytics engine with absolutely no code necessary. Price optimization allows you to take into account various inputs that weren't previously possible manually. This lets retailers gain more accurate insights into optimal pricing strategies. We've now come to the end of our session. Thank you for joining us today. We hope you've gotten something valuable out of this event and are ready to start your journey on machine learning-driven price optimization. Let's continue this conversation on our Slack community channel, where we can help answer any and all of your questions. Or if you have a use case in mind and would like more specific help, simply book a free demo with us. Alternatively, if you're ready to take the engine for a spin, you can sign up for a 2-week free trial. Thank you. Have a wonderful week.